Well, hello, everyone. I'm Paul Drabble, Global Marketing Director at Delta Q Technologies, a member of the Zappi Group of companies. I'd like to extend a warm welcome to everyone tuning in today for the final session of the 2026 Future of Electrification Virtual Conference. The topic is sodium ion, the next big shift in material handling, battery, and charging systems. It is my pleasure to introduce our speakers, Andrew Thomas, who is the co-founder and president at Acculon Energy, and Jamie Tolliday, who is a sales application engineer at Delta Q Technologies. Andrew has deep experience in the energy storage and battery technology sector, while Jamie works closely with OEMs, battery manufacturers, and system integrators to support the integration and validation of industrial charging solutions. Together, Andrew and Jamie will be presenting how sodium-ion batteries pair with validated charging systems to create a robust powering platform. Before we begin, if you have any questions during this session, please add them to the Q&A tab to the top right of your webinar screen. Note that your questions will be sent privately. At the end of the session, I'll facilitate a brief Q&A answering audience questions in the order they are received. With that said, I would like to hand off to Thomas and Jamie to begin the presentation.
Thanks, Paul. Like Paul said, my name is Jamie Tolliday. I'm a sales application engineer with Delta Q Technologies, here with Andrew Thomas.
Hey, everybody. Nice to have the chance to talk about sodium ion today.
Yeah, so I'll just give a quick overview of the agenda, what we're going to be talking about today. First of all, Andrew will talk a bit about why OEMs are starting to look into sodium-ion technology. He'll give an overview of the technology, how the batteries are built, how they work. Talk about optimal sodium-ion applications. I'll take over a little bit and talk about importance of battery and charger alignment, talk about how we validate the battery partners, potentially battery partners, bring them into our Charged by Delta Q program. And then I'll hand it back to Andrew to talk about deploying sodium ion in vehicles and talk a bit about the system interconnectivity within the triangle of operation, as we call it. And then we will get to some questions. So for now, I will hand it back to Andrew.
Awesome. So sodium has really increased its visibility in the headlines over the last year, in particular, as a technology family has really started to transition from laboratory to pilot run to gigawatt hour scale production to multiple plants and multiple suppliers and starting to have a diverse supply base. It's certainly helped in the world that leaders like CATL and others have kind of come into the fray. And the question is, why? What do technology companies around the world see in sodium ion that can eventually bring a benefit to original equipment manufacturers, dealers, and most importantly to the people that operate industrial vehicles? And so I would just kind of like to talk about the three main characteristics. The first that is probably most attractive if you think about material handling equipment that is well loved in the sense that it's well used, but not always well taken care of, and needs to provide durability to an operation, is the cold temp performance of sodium ion. This is a technology that is nearly immune to ambient temperature. It says on the slide here that we, depending on the particular blend of sodium ion, that you can see capacity at 90% of nameplate at -20 C. We've done our own testing down to -40 C, which is kind of the Goldilocks point where Celsius reaches an equivalency with Fahrenheit. So negative 40 degrees Fahrenheit, super, super cold. And even at those cold temperatures, this is a battery technology that can be both discharged and, very interestingly, still charged without the use of heaters at extreme temperatures. One of the other reasons that you're seeing this technology in the headline is around safety. And I kind of think of safety in a couple aspects. One is it is an inherently less volatile chemistry as compared to the broad family of lithium ion, from NMC to NCA to LFP. The other thing from a safety perspective that I think is quite interesting in the material handling space, again, where equipment gets used very, very hard, and even if your battery discharge indicator is all the way down to the last bar, that doesn't mean that the equipment stops being used. Is it's a technology that has the ability to discharge all the way to true 0 volts, and then not just discharge to 0 volts and become a brick, but through repetitive testing has shown the ability to deeply, deeply discharge and then pop back off the mat and provide energy to the user without significant degradation of expected cycle life. So super unique characteristic. The third piece, and kind of why the market is looking at sodium ion, is around cycle life. As the maturity of this technology has risen, particularly over the last 3 years, and a lot just in the last 12 months, we've seen under identical cycling conditions, some sodium ion chemistries actually outperforming LFP in terms of cycle life. So if you think about when is the time to begin adoption, these kind of characteristics are starting to ask the question, hey, is it now? So from getting a little more specific about not just the market, but the market segment that is material handling, these characteristics and others tend to have companies like Acculon thinking about two kind of specific entry points. One being in AGVs and AMRs, and the second being in outdoor or cold storage applications. So the first piece, and like the why on AGVs, it wasn't in the top 3 characteristics, but one other huge value for sodium ion is its power density is much greater than your common lithium ion technologies. So Acculon's products are fully rechargeable in 25 minutes. And so that type of power density, which is available pretty much regardless of ambient temperatures, becomes very interesting for your AMRs and AGVs, where recharge time and getting back to production is absolutely crucial for the value proposition, not just of the battery, but of a warehouse that uses autonomous vehicles. The second application fit that we think is particularly compelling is, again, in outdoor applications or cold storage, where battery technologies like lead acid, and we're talking about whether it's flooded or AGM or your TPPLs of the world, or your lithium ion, which either suffer a loss of capacity or a loss of capacity intrinsically, or a loss of capacity by needing, in some cases, to engage an internal heater just to maintain the ability to use the battery. Sodium ion is a completely passively heated, passively cooled system, very simple, very robust, and provides all of its nameplate capacity, even at very cold temperatures. So could be quite a good choice for your cold storage operators. There are some myths out there about sodium ion. Some say it's just a next generation of lead acid. It's fairly new to the market. There are lots of misperceptions. Sodium ion is a very interesting technology. While it has some similarities to lead acid, in that it is robust and that it can be deeply discharged as needed, it is, in fact, manufactured and built very much like your lithium-ion systems today. And there's still a tremendous amount of energy stored in every cell, every module, and every pack. All sodium-ion products are built with battery management systems that perform the same functions as you guys have experienced with your lithium-ion products. So there's certainly less sensitivity than lithium because the inherent safety risk is lower, and also the sensitivity to low states of charge, aka over discharge, and high states of charge is not quite like you would see for lithium ion, but all of your functional safety that's driven by the battery management system is the same. You can keep going, Jamie.
Yeah, so I'm going to talk a little bit about what we call our Charged by Delta Q program, which is basically a partnership between us and our battery partners. So Acculon being one of the newest ones. So I'll start by talking a little bit about why it's important for charger and batteries to have that alignment, to have that communication and that partnership for one thing, to extend to battery life. Obviously, like Andrew was saying, there's after a while the batteries will get worn down. So we want to make sure that we can extend that life as much as possible on the charger end by making sure that the batteries stay within proper voltage range, keep them within healthy parameters. In some cases, doing equalized charges depending on the type of batteries. Basically making sure that the batteries survive as many cycles as possible with limited wear in between. Next is performance. Obviously, efficiency is a big thing. You want to make sure that when you're charging the batteries, that as much energy as possible is being stored in those batteries rather than being lost to heat or being lost otherwise. So that's going to maximize efficiency, make sure that there's less wasted power. And both of those things feed into cost of ownership because, the longer your batteries last, the less often you have to replace them, obviously. So, saving you money there, as well as the less time it takes to charge the batteries, the more you're able to use them. So, so less downtime, fewer replacements. And then safety, obviously, is a big one, as Andrew touched on. And that's, there's an incredible amount of storage of energy stored in those batteries. So we want to make sure that that there's redundancies in place, that everything is, that avoiding disaster. So basically making sure that the charger isn't overcharging the batteries. If there's something wrong with the batteries, then those things, the BMS will be able to identify those things, take necessary precautions to avoid any safety issues. And finally, reliability. You just want to make sure that the batteries are being charged consistently. So that might be, weather dependent, temperature dependent, making sure that, 100% state of charge means 100%, and, you don't want to fully charge your batteries and then, take your vehicle out and then it dies within 5 minutes. It's, obviously something wrong there. So, yeah, just making sure that a charge is a charge. So again, just considerations when the benefits of battery and charger validation is to maximize uptime, reduce cost, prolong battery life, save time, boost performance, and ensure reliability. So back to the safety point, I just wanted to touch on there's everything in the system kind of has some responsibility for maintaining safety, and there's redundancies between those, but just to go kind of over the basics of it, the battery itself obviously is a mechanical enclosure, encases all the cells, making sure there's insulation between the electrolytes. There's for certain batteries will vent off any electrolyte when the electrolyte starts boiling, and making sure that there's adequate, that the battery is able to swell with heat, but without, obviously you don't want the case to crack. So wanting that to be robust and reliable. The BMS, that being the battery management system, as Andrew touched on earlier, will monitor cell balance, as well as temperature, just making sure that all the cells are healthy, that they're all equal voltage. Often, if you have one cell that's out of balance with the others, that can cause some problems. It could cause imbalance in charge, and potentially just cause problems in the long term with the other cells. So having the BMS be able to track the individual voltage of each cell is important. We'll also protect between against overcharge or over discharge. So basically, if the battery is going into a point where it's outside of its voltage range, either because it's been discharged too low or is being charged too high, that it have some kind of some protection, usually a relay to cut off the output from the charger or the load, just to keep it within that proper range. And finally, the BMS will communicate usually through CAN, either CAN open or J9239, communicate to the charger, to the vehicle, to any other systems in place to alert those elements of anything that's going wrong, or even just to set the charge parameters, just basically communicating any what's going on with the batteries. Finally, the charger obviously receives those messages from the BMS. So if the BMS is sending it charge parameters, it will maintain those. Otherwise, it might be the case that the charger is using its own what we call a local mode algorithm, where it's responding to the voltage of the batteries to set its current levels, and basically just maintaining those charge parameters, making sure that it's charging correctly. The charger will also be able to tell if the battery becomes disconnected, which means that depending on the cabling that's being used, would mean that there's, you wouldn't want to have just a charger outputting a high voltage if it's not connected to anything that could potentially cause a short. So making sure that it's able to detect any disconnect from the batteries or a short circuit across the outputs, and then responding to feedback, so that again, could be communication from the BMS through CAN controls. Might be that the charger is using a temperature sensor and needs to adjust based on the battery temperature. But basically responding to that feedback from the battery or from the environment to adjust its output. So talking a little bit about the validation program for Charge by Delta Q. So we want to, it's basically when we're bringing new battery manufacturers into our program, we want to, we have a few questions for them. We want to get some information about their batteries, the application, make sure that they're going to be a good fit for our program. So we kind of we have some things that we want to check. So charge profile validation, meaning kind of what does the charge profile or algorithm look like in terms of voltage and current. We like to know the cell chemistry. So in Acculon's case, we're dealing with sodium ion, which is fairly new to us as well. So it's certainly something that we are still learning about ourselves, and so being able to get that information from Acculon and have that communication is important to us to learn going forward what sorts of requirements are needed for these types of batteries. Battery capacity and voltage obviously is something we need to know just to make sure we have what sort of charger is going to be required, if it's going to be a higher power. We have various voltage models, so just making sure that we have the proper charger for the application. So the battery management system, the BMS, like I mentioned earlier, how that operates. Is it able to cut off the charger if there's something wrong with one of the cells, or if there's something's going on with the battery that needs to cut off the charge. That all feeds into charger compatibility, like I said before. Making sure that that the voltage and capacity is correct. If there's any other requirements that we need to meet to align. Charge disconnect protection, like I said, with the battery management system, just to make sure that there's some fallback safety measures in case something's going wrong, needs to cut off the charge. Thermal and technical safety. So again, is the BMS, we want to make sure that that it's tracking those things, that there is monitoring of the temperature, and that there's safety mechanisms in place there. And mechanical construction. Obviously, just making sure that the batteries are robust and safe and reliable. So a few things that we send as a checklist when we're establishing these partnerships. We ask for a signed some sample charge plots, just so we can see okay, what does the profile look like when they're charging the battery. In Acculon's case, they are doing remote control charging, so they are sending CAN messages to our chargers to control the charge. Something we've talked about down the road is doing a customized algorithm for them, but as of right now, they are doing remote control charging. So we wanted to know, what does that look like? What would an algorithm look like if and when we design that for them? Cell chemistry and manufacture of cells. So again, obviously it makes a difference if they're doing, sodium or lithium ion or lead acid, just to give us a sense of what's that going to look like? What similar algorithms have we designed for those sorts of applications in the past? Photographs. So we just want to get, we want the manufacturer do some testing for us. Obviously, that's when they're doing their charging and they're gathering the charging plots. We want to see just see their test setup and give us an idea of how they've wired our chargers and what sort of applications they're putting them in. And finally, we just want to confirm that that the BMS does have some kind of disconnect. This isn't always the case with lead acid batteries. This might not be the case, but anything that with lithium and certainly new technologies like sodium ion, we want to have that redundancy of being able to, like I said, if something's going wrong with one of the cells or something's going wrong with the battery, whatever the case may be, that it's able to cut off the charge to sort of nip that safety hazard in the bud before as quickly as possible, basically. There is also we do some meta-analysis here of as we're gathering this information from the potential partner. We want to make sure that that they're responsive and that it feels like a good relationship. Just if in case for when we have that partnership going forward, that we're really able to rely on them as a partner, and so there's an element to it that is vibes based, as the kids would say.
Hey Jamie, can I add one piece on that slide?
For sure.
Just on your checklist, one of the things just to kind of make the audience aware of that I think is particularly important is even one layer down in the Matryoshka from like manufacture of cells to cell chemistry is sodium ion is a family, and right now the materials that are used and the method of manufacturing the materials and the method of manufacturing the cells and then controlling them is diverging right now at this kind of state of the marketplace. So a layered metal oxide cell from supplier A, from supplier B, from supplier C, can have an important impact in the charge curve and this validation activity. And even from the same manufacturers, moving from formats from small cylindrical to large cylindrical to prismatic is something that I think is important to note. Before you even get to the conversation of is NFPP better than layered metal oxide, better than polyanion, for a particular material handling application. So we thought, Jamie, when we went through the process with you guys, that was like a pretty heady choice for your checklist because it has real implications, in your points 1 through 8 in your validation process.
For sure, yeah. Thanks, Andrew. Yeah. There is quite a bit of variability within those chemistries as well. So yeah, definitely. Something we consider as well. So thanks for mentioning that. And so just getting a bit deeper into the Charge by Delta Q program, sort of a couple of there are some levels to it. Like I said, right now Acculon is doing remote control charging of our chargers. So we consider that to be the charge compatible validation level. So that means the battery's been tested by, in this case, Acculon, battery and charger together. They're using existing algorithms, or in this case, like I said, using remote control charging. But something we've talked about in the longer term is getting them on charged optimized, which means that the charger will have a customized algorithm for the battery, which is typically when we're we're getting into distribution, something they prefer since they like to be able to sort of match things after the fact rather than have a full being fully integrated into the vehicle all at once. So yeah, kind of opens up a few more options. Simplifies things a little bit for the distributors and OEMs. Go ahead, Andrew.
Yeah, no, definitely. I think the technology is not just interesting and valuable to OEMs producing new equipment, but interesting for dealers and distributors who may be looking to replace lithium or lead acid batteries in the field. And I really think that's going to be a critical focus area between our two companies, is rapidly moving from being compatible to being optimized, all the while using the same Delta Q hardware that is highly validated, and there's a huge installed base and huge experience in the marketplace. With your common products like the IC650, and even some of the larger, newer products like the XV3300 that we've adopted in some applications as well.
Yeah, so just taking a look at this specific case of Acculon, so the information we requested, they provided us a report, gave us some charging curves from their sample charge testing. So you can see here on the upper right the current and voltage levels that they were sent to the battery during charging. So to us, like I said, we have limited experience with sodium ion, so we are learning ourselves, what sort of charge profiles are being used here. So so when I saw this initially, I thought, okay, yeah, it's IUI, it's constant current stage, constant voltage, constant current, which is similar to how most lead acid batteries charge. So to us this is familiar, it makes sense. And they provided some pictures of their setup. So using the left picture there with the IC650 charging the battery, and then on the two other pictures there with the XV being used, XV3300. So some variability there with their power levels. So so it gives us better understanding of the sorts of applications, the sorts of chargers we could be using in their applications. And so that gives us it all kind of gives us a better picture of, okay, if we're going to design an algorithm for them down the road, what's that going to look like? Is there what sorts of considerations will we need to take, and what sort of testing has been done? It makes us more comfortable with having them be a partner, and it's like I said, through the process, it's we've been in constant communication, and it's we feel like we can rely on them when questions come up from OEMs, that you can reach out and get questions answered, and do some more testing if necessary. So definitely been a favorable partnership so far. And I will hand it back to Andrew to speak on deploying sodium ion in real vehicles.
I think this slide is a lot of words, but a fairly simple message, Jamie, that Delta Q and its customers are used to, that there's no experience like your own experience. So having lab data from us, for which we have terabytes on sodium ion at this point of data from one of the testing businesses that we own, is certainly useful, but nothing beats taking the charger, taking a sodium ion product, and seeing what happens when it's in your vehicle. Because certainly sodium, just as LFP is different than NMC, is different than AGM. Sodium ion has its own characteristics as well. And eventually folks are using the equipment for the customer experience that comes from the machine, and for the functional safety that's built into that machine as well. So we have learned a ton putting our sodium ion products in multiple configurations, both low voltage and high voltage, single module, multi-modules, series and parallel configurations. You learn a lot just getting into the real world, and it's certainly useful. We encourage all of our customers to have your own data set, and we'd love to support you in that effort, in providing batteries and chargers, which help shorten and steepen the learning curve on sodium ion. Jamie, feel free to jump in as well, but just a few highlights. Sodium ion, guys and gals, is here. The maturity of the technology is quite high. Acculon and others are establishing manufacturing capacity for sodium ion products focused on material handling in North America. And I think 2026 is going to be a huge year for folks starting to deploy and get real data from the field in the material handling application. Along the way, it's new. It's a time for deployment, but also a time for learning along the way. So, I think it's crucial between battery suppliers, the charger, your powertrain provider, and most of you as OEMs, communication, data exchange, cannot be overemphasized. Ultimately, what we're after is what you're after, which is a reliable piece of equipment that your customers love. And that's I think Jamie, that's what this is all about.
Definitely, yeah. And yeah, like we say here, I mean, it's important to get us involved in the early stages of planning, to make sure that we're aware of the requirements, and that we have a team of engineers on hand to help you through that. To establish that partnership and make sure that everything is running as expected. So, the reason for the Charge by Delta Q program is that integration, and that having those partnerships in place so that we have so that things go as smoothly as possible when it comes to integration within the vehicles.
Awesome.
Okay. So thanks, everyone. If you still have any questions, you can feel free to throw them in the Q&A there. It looks like we have a couple already.
That's right. I'll just jump in, Jamie. We had a couple of polls that were going on while the presentation was happening. We had a few folks that provided some perspectives. The first one was which application makes the most sense for sodium to replace lead acid or lithium. There's only one response, and that was someone said class 3 there. There was another poll there concerns about sodium. No one gave an answer there. And the third one, what is most exciting about sodium? And 57% thought that the immunity to cold temperatures was probably the most exciting thing. The second, at 29%, was long asset useful life. And coming in third at just under 15% was 0 volt capability. Okay, so that's the results of the polls. So we just have 2 questions that were submitted. So the first one, when cells are discharged to 0 volt, can the same charge algorithm be used to charge back to full capacity? Sounds like one for you, Andrew.
Yeah. The short answer is the way that the integration is being done now is via CAN, and so the battery's controlling the charger. So is the charge algorithm exactly the same as a standard algorithm? No, it's not. Much the same as the charge command is dictated right now by things like external temperature and state of charge. So in the future, what we're going to is an algorithm that kind of catches them all. For which case there will absolutely be an ability to use a singular algorithm to bring the product back from 0 volts.
Okay, so the next question and the final question, perhaps either of you can have different perspectives on the answer here, but what do you think is, in all your experience, the most important factor or biggest challenge when you are pairing a battery pack with a charger?
Yeah, I can start that off. Well, I would certainly say the most important is safety. So making sure that there are redundancies, safety factors in place to prevent any kind of disasters. So having cutoffs from overcharge or whatever else, having that relay to be able to cut off the charger if something goes wrong, which can kick in before the charger responds to that communication. I think that's the most important in terms of biggest challenge. It's a tough one. There's I think
Jamie, I think you froze.
Yeah, I think you froze there. There's certainly a lot of.
Can you try that again?
Yeah, you're kind of looking
How
up.
far did I get?
You froze. Yeah.
Okay. Sorry about that, everyone.
Sorry, the other biggest challenge you were saying?
Yeah, I think it's a tough one to say. I mean, I think it's things kind of come up as I guess it's just hard to account for everything right at the beginning. There's certainly things that come up in the field that you kind of have to adjust to, and I think just sort of the I guess it's the unknown and sort of what sorts of things might happen that we don't expect. So just being able to kind of roll with those punches, find solutions, work with the battery manufacturers to come to solutions that work for everybody. So
well, there's certainly a lot of factors. There's intended purpose and duty cycles involved, and operating conditions, and the charging situation. Like certainly, how much space you have to work with too. Lots of factors for sure. What do you think, Andrew?
Gosh, This may not seem like a technical answer, but I think the most important factor is just a willingness to work on both sides. It's kind of what drew us to Delta Q is you guys don't just understand your products, but you understand and have a high motivation to make them work for your customers. And I think that's just invaluable.
Okay. A couple of more questions just rolled in. How do you see aluminium ion batteries comparing with sodium ion ones?
So aluminum.
Sorry, I'm Australian, so we say aluminium.
Aluminium. So aluminium ion batteries are a newer technology, still fairly nascent. I think the promise of that particular technology family is probably more akin to like somewhere between like a supercapacitor and a lithium titanate battery. So very, very high rates of charge and discharge available at the sacrifice of energy density. I know there's been like some excitement, particularly in the investment community, about the technology, but certainly at this point not to the point where production is scaling up even to pilot level around the world. So exciting, but coming. Think super high power would be kind of my off the cuff place where that fit application wise.
Okay. All right. Looks like the final question here. How is sodium ion different from LFP in terms of charging power limitation at different temperatures and other factors in the sense of being able to replace LFP with sodium ion batteries in existing systems?
Jamie, you want to take a first cut?
Yeah, well, one thing I noticed, as I pointed out earlier when we were reviewing the charge profile there, is that you do with sodium there is it is an IUI compared to being constant current, constant voltage, constant current. Whereas lithiums tend to just do IU profiles; they don't have that final constant current stage. So that is one thing that I noticed, that it is more similar to lead acid charging in that way. Maybe you can expand on the reason for that constant current stage, Andrew.
It's just one of the characteristics of the electrochemistry. But yeah, I think the charge curves and the shape are quite different between LFP, where there's, as people have figured out over the last 15 years, really tough to understand if you're at 85% SOC or at 15% SOC. Sodium ion, in particular, the layered metal oxide variant is quite different in terms of shape. I think the point on power limitation is really what is distinct between LFP and sodium ion, and that even at very low temperatures, the sodium, it is safe and part of the our algorithm to accept a fair amount of current, even at low temps, even at very low states of charge, which kind of allows the machine and the users of the particular application to go about their day in a normal way, with less thinking about, hey, what does the battery in this machine need? It's kind of like, oh, what do I need? And the machine will keep up with me.
Okay, looks like that's the last question answered. But I'd like to thank Andrew and Jamie for coming on to present for today. Here are their contact details if you want to reach out and connect with either one of them. You got more questions? Maybe look them up on LinkedIn. You can connect there as well. So yeah, that essentially brings this session and the virtual conference to an end for 2026. So we really do hope that you found this presentation and any others that you attended in the last 2 days to be educational and very insightful. They're all being recorded. You'll have a link to access all of the sessions if you're a registrant, and we'll send that out in the coming weeks. So having said that, being part of Zappi Group, we'd like to thank all of our expert speakers and all of the attendees for being part of this year's conference. So, and we do hope that we see you again at future events, and wishing you a terrific day. And thanks again for joining the fun. Take care, everyone. Thank you.